Hello, let us start the series of sessions on digital electronics. We will begin with the digital number system. There are basically 4 number systems used. The most common number system that is used is decimal number system. Deci meaning 10 uses 10 symbols 0 to 9. The first 10 digits that are used in a decimal number system. The next number system that we are going to get familiar is the octal number system. Octal number system will be using 8 symbols from 0 to 7. And the third number system is hexadecimal number system. Hex is 6 and deci is 10, and therefore hexadecimal number system will be using 16 symbols, and these 16 symbols are 10 decimal digits from 0 to 9 and 6 alphabets from the English language. And the last number system is the binary number system. Bi is 2, and therefore binary number system uses only 2 symbols 0 and 1. So let us get familiar with each one of them and see how each one of them is represented. First and foremost is the decimal number system, which uses 10 symbols which include the decimal numbers from 0 to 9. And this is the number system which is most commonly used by human being. The base or the radix of the decimal number system is 10. It uses 10 digits 0 to 9, and any number, any value, any number in decimal number system can be represented using a string of these 10 digits. For example, 1947 is a decimal number which is normally read as 1947. The suffix 10 represents that it is a decimal number. It's essential to use the subscript using the base of the number system to discriminate one number system from the other. And decimal number system is easy to count. Probably when the human first started counting, he might have used his fingers to count the objects, and therefore this decimal number system would have existed. And any decimal number can be represented as a string of the 10 decimal digits. So here we have an example, a decimal number which is read as 4782, which can be written as a sum of 4780 and 2, and in turn this number 4000 can be written as 4 times 10 power 3, and 700 as 7 times 10 power 2, and 80 is 8 times 10 power 1, and 2 as 2 times 10 power 0. So here each digit in the decimal number, that is 4782, has got weightage, and this weightage is represented as powers of 10, and the digit, the rightmost digit 2 having the least weightage as 10 power 0, and as we move towards the left of the decimal number, the weightage for the digits, the order of the weightage keeps increasing. And here the number 10 represents the base or radix of the decimal number system, and the powers of 10 represents the weightages of the digits. And in 4782, the rightmost digit is 2, and we call this digit as the least significant digit because this digit has got the least weightage, and the digit 4 is called as the most significant digit as this digit has got the highest weightage, as you can see. Next comes the octal number. An octal number will have 8 symbols from 0 to 7, and hence the octal number, any octal number can have a string of symbols ranging from 0 to 7. So here in our example we have a 4-digit octal number which is read as 4732 to the base 8, indicating that it is an octal number. And remember that this number cannot be read as 4732 as 4 is not having a value 4000, and 7 as 700, 3 is 30 and 2 is 2. Instead 4 has got a weightage of 8 power 3, and 7 has got a weightage of 8 power 2, 3 has got a weightage of 8 power 1, and 2 has got a weightage of 8 power 0, and hence the value of digit 4 is 2048, the value of digit 7 is 448, the value of digit 3 is 24, and the value of digit 2 is 2, and hence this octal number will be having its value equal to 2522 in decimal system, and hence we have the radix 10 here, indicating that this is the decimal equivalent of the octal number 4732. And as you can see that 8 is the base or radix of the octal number. Let's now move on to hexadecimal number system, which will be having 16 symbols, and this is the most convenient way of representing binary numbers, which we will be seeing in future, and it uses decimal numbers from 0 to 9 and English alphabets from A to F. And example hexadecimal numbers are, some of the examples are 4 to A7, 2950, 7DE4, and here H represents that it is a hexadecimal number that we are representing, and the base or radix of the hexadecimal number is 16, and therefore we can understand that the weightage of hexadecimal digits will be powers of 16. Let us try and understand the decimal equivalent of the hexadecimal numbers, because the hexadecimal number system also includes the first 6 alphabets. We need to know the numerical value of these alphabets. The hexadecimal number starts with 0, whose decimal equivalent is 0, and the next digit is 1, and the decimal equivalent also is 1, and it goes on until it reaches to 9, whose decimal equivalent is also 9, and the next digit in hexadecimal number system is A, and the hexadecimal equivalent is 10, and B is equal to 11, C is equal to 12 in decimal, D is equal to 13, E is equal to 14, and F is equal to 15. This is how we will have the decimal equivalent of the hexadecimal numbers. Let us take an example hexadecimal number and try to understand how to get the value of it. The hexadecimal number that we have is 4E82. Here the subscript 16 indicates that it is the hexadecimal number. And the weightage of 4 is 16 power 3, the weightage of E is 16 power 2, the weightage of digit 8 is 16 power 1, and the weightage of 2 is 0. And hence powers of 16 will be the weightage for the hexadecimal digits in a hexadecimal number, wherein the rightmost digit will have the least weightage, that is 16 power 0, and as we proceed towards the left, the degree of order will increase, and hence the decimal equivalent of, or the decimal value of this hexadecimal number is given as 20,098, which is the decimal equivalent of the hexadecimal number 4E82H. And as you can see, the base or radix of the hexadecimal number system is 16. The next number system that we have in our store is binary number system, which is the most important number system in digital electronics, because this is the number system that is used by all digital systems. And binary number system will use only two values, which are 0 and 1, and these two values represent two states which could be on and off, or it could be light on and off, high voltage or low voltage. And the base of the binary number system is 2, and a binary number can be represented as a string of these ones and zeros. An example binary number is 101101. The base is 2, and therefore with any binary number we should be inserting this subscript 2 to indicate that this is a binary number. And any binary digit is called as a bit. So 0 and 1 are called as bits in a binary number system. And if we take any binary number, then the bits of the binary number will also have their weightages, and the weightages of the binary bits will be powers of 2. So the binary bit 1 is having a weightage of 2 power of 4, and the next bit 0 will have the weightage 2 power 3. The next bit will have the weightage 2 power 2. The next bit 1 will have the weightage 2 power 1, and the last bit, the rightmost bit, will have its weightage 2 power 0. And therefore this binary number will have its value as equal to 16 plus 0 plus 0 plus 2 plus 1, and that is equal to 19 to the base 10, indicating that the decimal value of the binary number 10011 is 19 to the base 10. And as we all know, the base or radix of the binary number system is 2. So with this we come to the end of the introduction of the number system, and in the next class we will be studying about the interconversion between these number systems. And here in the in terms of binary number, because the digital system will be using binary number for its operation, and therefore it is essential for us to know that we call the rightmost bit as the least significant bit, because the weightage of the rightmost bit is 2 power 0, which is the least weightage, and the weightage of the most the leftmost bit, in this case the leftmost bit 1 is 2 power 4, and therefore this bit is called as the most significant bit. Thank you. We'll see you in the next lecture.